Next up is how the graph bends. Ooh, I think we can do it. So we'll do step 4, which is concavity. For that I need the second derivative, but this is easier than you might think. I'm not going to look at this version. I'm not going to look at this version. I'm going to look at the original. But maybe we should clean it up a little bit. So let's just write it over here. What was it? 5 over 3 x to the 2/3 minus 10 over 3 x to the negative 1/3. That is the nicest version to calculate the second derivative from. Might not be the nicest version to use in step 3, but it is now. So I have 10 over 9 x to the negative 1/3 plus 10 over 9 x to the negative 4 over 3. Now I need to clean this up, of course. I'll take out a 10 over 9, and I'm going to take out the smallest, or most negative rather, power of x, which is negative 4 over 3. What do I have left? I have actually x plus 1. And by doing that, I have a nice bracket here, easy to work with. So I have 10 over 9, x plus 1, x to the 4 over 3 in the denominator as my second derivative. So these ones are actually not bad at all. So I look at where my second derivative is equal to 0. Having done the work to simplify, it's as easy as saying x equal to negative 1. Where is the second derivative undefined? Having done the work, it's when x is equal to 0. So I almost have space for my table. I'm going to squeeze the table in here. I think we can do it. There are only a couple of pieces here. I'm going to separate it by negative 1 and 0. Together, these pieces give me the second derivative. I think we can fit everything in. Now, 10 over 9 is always positive, positive, positive. X plus 1 is 0 when x is negative 1. It's going to go negative to positive. X to the 4 over 3 or x to the 4 cube root is 0 when x is 0. Sorry, we didn't say. X plus 1 is 0 when x is negative 1. It is in the numerator. It makes the function 0. X to the 4 over 3, or whatever version you want to look at, is 0 when x is 0. It's in the denominator, undefined. I work inside out, which is why I want to look at the root version instead. X to the 4 is always positive. Cube root of a positive number, positive. So I have on the first section, negative, positive, positive. So I'm bending down, then up, then up. Let's write these sentences. First, f is concave up on, can I say negative 1 to infinity? Yes, I can, because I'm referring to the function, which is defined everywhere. F is concave down on negative infinity to negative 1. Next question. Are these guys inflection points? Which one is an inflection point? They're both points. They're contenders because they came out of my check here. but the concavity has to change as I pass over these zeros. It does for -1, it doesn't for 0. So only this guy is an inflection point. They're equally important in my table, but an inflection point is only one where the concavity changes. Now let's see what we get here. Alright, graph time. I'm bending down -1 and to the left. Whoa. -1 is sitting somewhere over here. But what is the y value? I said there's a point. What is the y value when x is -1? So let's go all the way up. X is now -1. And calculate what is the y value. So I have the cube root of -1 to the 5th, which is going to be -1, minus 5 times the cube root of -1 squared, which is 1, and I get -6. -6. So, way down here is -6. I'm gonna bend down to the left. So I'm gonna bend this way as I'm heading to infinity. Not a big bend. Then I'm gonna bend up through here, of course. I can see that bend clearly. But also here, I'm gonna bend up. So let's finish the graph in a somewhat neat way. And then we have covered all our types of functions. So we have our vertical tangent line here. Let's just take care of the other side, the right side. Let's put it over here. Horizontal tangent up, and away. And then I'm going to go vertical tangent towards this horizontal cup. Now I know this is sitting here at -4.7622. And I'm going to go vertical tangent, bending up. I'm just going to exaggerate this a little bit so you can see. Come on, not straight. So you can see the bending occurring here at -6. Up, x equals -1. And then I bend down. Not straight. It looks very straight. Whoop, that was a wobble. Down to infinity. So I get these very interesting shapes in my graphs when I allow for fraction powers of x. But all the information still comes from my previous steps and my tables, like before. Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.